A very good morning everyone. So yesterday we had a discussion on paper 1, right? So mathematics softener that was last Sunday for 2022, okay. So a detailed solution or a detailed basically analysis I have done for paper 1. So as I have discussed, today I am going to discuss paper 2. So usually paper 1 and paper 2, the syllabus of the paper 2 is much vast, right? Even if you look closely in the syllabus of calculus and the real analysis, you will find that difference over there, right over there. So the calculus and the real analysis, the limits, continuity and differentiability same is asked in the calculus portion also, but again in the one variable, left hand limit, right hand limit, all those things, and in the real analysis same topic, but the epsilon delta comes into the picture, so some detail is there. So paper 2, let us start, okay. First question, show that the multiplicative group G 1 minus 1 iota minus iota is isomorphic to the group G dash, this is Z4. Now two groups were, this was given, right, and your job was to prove that they are isomorphic, okay. So now see algebra, the model algebra part, that is the first topic of your paper, first subject of your paper 2, actually it requires a lot of time also. This particular topic, group theory, ring theory, and the small portion of field is also there, and the real analysis also, it takes some time. But again same things I will say as I have said yesterday, that even you find these topics difficult, at least go through each topic. If the question is asked, you know, it's a very difficult question and you are not able to attempt it, just leave it for the time being in the question, in the paper, don't waste time, right. But this was an easy question, you can attempt. We have group G and G dash, you have to prove they are isomorphic. That means you have to define a function that is well defined, 1 1 onto and isomorphic. So what we can do, see, you can observe a simple property here, they both of these groups are cyclic group of same order 4. So if you just send the generator of G to the generator of G dash, your job is done. If I talk about G is 1 minus 1 iota minus iota, right, and G dash is 0 1 2 3. Identity, even if you see the order 1 2 4 4 1 4 2 2, right. And what I am telling you, to define a function from G to G dash such that generator goes to the generator, and you have to define this as a homomorphism, right, this has to be a homomorphism. So you actually try the properties, this to the power n, right, you can take that n over here, I raised to the power n, and this is n, right, reduce it in Z4 and you will get a homomorphism. Please prove the all the three parts, homomorphism 1 1 and on 2. This is not an even infinite set, see, this is not an infinite group, only 4 elements are there. You can explicitly associate each element of G to an element of G dash, right. Now see, if this is my G, this is my G dash. For G, I have 1 minus 1 iota minus iota, 1 minus 1 iota minus iota, and this is 0, 1, 2, 3, 4, 0, 1, 2, 3, 0, 1, 2, 3. You can just simply associate the numbers to make a function over here, because we have finite. Even for finite, I have just 4 elements, no problem in that. So, I have started it with iota to 1, right. So, let it be iota to 1, identity with identity, and minus 1 to 3 minus, sorry, this has to be minus right, 1 to 0, iota to 1, and then minus iota to minus 1 to 3, and minus iota you can send it to 2. Minus iota, iota both have order 4. Okay, I have done. So, this is basically, just a second, this is 4 order, right? Yeah. So, 1 and 3. So, you see here you have basically, you can define two homomorphism, iota to 1 or iota to 3, and similarly the other way around, minus 1 to 1 and minus 1 to 3. Okay, you have 2 choices. So, prove it, and there was nothing in this question. Now, this was the first B, because since it was the mandatory section, you have to attempt all the questions, right. Now, B part was, if f of z is u plus iota b is an analytic function of z. Okay, see, if this is an analytic function, it is given u minus v is given, then find fz subject to the condition f of pi by 2 equals to 0. Okay, you can use that pi by 2 equals to 0, there is no problem in that. But how to make that? You know, usually if u is given to you, you can find that v, because this is given analytic function. So, you can use the CR equation, right, Cauchy-Riemann equation, ux is equal to vy, ux is equal to minus vy, right. But over here, u is not given, instead u minus v is given. So, make a function whose real part is u minus v, because we know if real part is given, how to calculate the v so that you can get f of z as whole, right. So, what I will do, I will make a function whose real part is u minus v. Okay, how to do that? See, f of z, it was given to you u plus iota v. So, iota f of z, it would be iota u minus v, right. What you can do? Just add these two. If you will add these two equations, you will get f of z plus iota f of z equals to u minus v plus iota times u plus v. First step is done, that is, I have, let it be capital F of z. Okay. Now, I have a real part of this function that is known to me, right, and you observe that this is also a analytic function. It is not a very big task to prove this is an analytic function, since u plus iota v is analytic function. So, there will be no problem in that section. Now, I know the real part, all I need to real part of f of z. This is real part of f of z. I want to find the imaginary part of f of z, given f of z is analytic function. So, again use the CR equation. Use the CR equation and done. But even the CR equation can create a little bit of problem here. Why? See the function. it will take some of your time, because it's a kind of complex function. X and y are introduced in such a manner. It will take some time to do ux, uy, then vx, vy, all those things. So instead what you can do, you can actually reduce this also. See, what is this? You can convert this. If you take this minus common out, this is nothing but cos hyperbolic. Change this. Same kind of observations you can make in the numerator also, just to reduce the expression of the given u minus v. Okay. So what you can do, u minus v, it is already given to you, that is cos x plus sin x, cos x plus sin x minus e raised to the power y, minus e raised to the power minus y upon 2 cos x minus e raised to the power y minus e raised to the power minus y. So what I am saying is, just take that minus common out. This is nothing but, I am just writing the denominator here. Denominator will be reduced to 2 cos x. If you take minus common out, e raised to the power y minus e raised to the power minus y divided by 2, multiply it by 2. So it becomes 2 times cos hyperbolic y. Right. After that you can so e raised to the power minus y. Now as such I can't introduce a sin hyperbolic y or cos hyperbolic y, but you can make a relation. Now, because what is your sin hyperbolic x? See, this is e raised to the power x minus e raised to the power minus x by 2, and cos hyperbolic x is e raised to the power x plus e raised to the power minus x by 2. Now again you can change this by subtracting. Sin hyperbolic minus cos hyperbolic will give you that expression, right? Just minus. So you can write it sin hyperbolic x minus cos hyperbolic x, adjust the 2, take that 2 common out, basically try to reduce this expression. Again, instead of doing all those CR equation, there is one more thing you can use. We have Milne's method, right? If you know this is the analytic function, basically you know f dash z, what is that? That is ux minus iota times vx, right? And that vx can be written as ux plus iota uy. So basically you don't need to perform all those CR equation here. Just apply this theorem, this method, and this is your u, this is your capital U, this is capital U plus iota capital V, this is f of z, right? So what I am saying is, you have your capital U, this you have reduced your expressions, just differentiate it with respect to x, differentiate it with respect to y, obtain an expression, whatever is your answer, integrate both sides to obtain your fz. Okay. So this was a immediate consequence of the CR equation, Cauchy-Riemann equation, and you can use it. Also just reduce the expression u minus v, that will be very useful in the calculations, otherwise it will take some time. So this was question number 1, second part, B part, right, from the complex analysis. Next, again question number 1, C part, test the convergence of integral. Okay, Convergence of integral, a same kind of question, not the same question, same kind of question was asked in paper 1 also in the portion of calculus. Over there I have divided that integral, it was from 0 to 2. So, I have divided that in two integrals, 0 to 1, 1 to 2, and then I discuss. Over here in that last paper, test was not required. The direct result of your improper integral was enough. There was no test required. Over here there is a simple test where whenever you see sin x, cos x, they are very easy. Why? Because you know the upper limit of the modulus, right? Modulus of cos x is less than equal to 1. Then you write modulus of cos x upon 1 plus x square is less than equal to 1 upon 1 plus x square. Limit comparison test. They are asking about 0 to infinity cos x upon 1 plus x square dx. You calculate first 0 to infinity 1 upon 1 plus x square dx. What is this? This is limit, let us say y tends to infinity 0 to y 1 upon 1 plus x square dx. This is nothing but tan inverse of x from 0 to y and limit y tends to infinity, right? And for that y, again if you apply the limit, it will be pi by 2. So, this is convergent. This is convergent. Now, if this is convergent by comparison test, this is convergent. Yes, this question require a test, limit comparison, as you can see. Over there there was no test required, but again it was not a very difficult question from the convergence part, right? Proper and improper integral, we have done this. So, this was C part. Then again this was question number 1, D part. This was the question of again complex analysis. Fz, a function is given and you have to expand this Fz in Lorentz series, valid for the regions this and this. Okay, two regions were given. When they are talking about the Lorentz series, Lorentz series is, we expand in the Lorentz series in the region annulus, and that is what is given to us, z minus, this is the annulus region, both of them. For the first part, you see, if you in the starting let z minus 1 is equal to 2, right? In that case, z minus 1 is equal to 2. In that case, your first condition becomes, sorry, this is u, so it becomes this, or 0 less than modulus of u by 2 less than 1. You can write it like that also, right? And the Fz is 1 upon z minus 1 square. So, if you want to write everything in terms of z minus 1, it becomes z minus 1 whole square and z minus 1 minus 2, right? So, basically this becomes, this expression, it becomes 1 upon u square u minus 2. All you need to do here is take 2 common out, so that you can get an expression like that. So, this becomes 1 upon this is just take minus 2 common out instead, minus 2 u square, it becomes 1 minus u upon 2. You know how to expand that, given u by 2 modulus is strictly between 0 to 1, then I can expand this series. If I open this, it is valid only if this is true. and because it was already given to me, I can expand this, it can be written as minus 1 by 2 u square and 1 minus u by 2. So, this is 1 minus u by 2 raised to the power minus 1. This becomes minus 1 by u square 1 plus u by 2 plus u square by 2 square plus u cube by 2 cube and so on for u by 2 between 0 to 1, right. Now, just need to substitute the value of u as z minus 1, back substitute the value of u as z minus 1, open the brackets and you find the expression in terms of z minus 1, open up the bracket and you will get a series, that is your Lorentz series. This was the easiest question from the Lorentz series section. This was the first kind of question. In the Lorentz series, this was the first kind of question that we have discussed. So, very easy. Same kind of calculations you can do for the second part as well. Okay. You have to adjust your fz in the manner z minus 3 upon 2 such that it is true, and again apply the same formula, open up the same series and you will get the Lorentz series for the second expression as well. Okay. Now, this was D. Then we have E. It was from LPP. The problem was this, two-phase method, question number 1. First of all, whenever in LPP you see minimize, what you do? You change it. You take the another function. For example, z is my function over here. So, this is not what you solve. You solve the maximization problem. So, maximize some z prime where this is actually equal to minimum value of z. Minimum value of minus z, right. So, it becomes minimum value of minus x1 minus x2. So, basically you are solving the problem maximum of z prime, and that z prime is minus x1 minus x2, minus x1 minus x2. Two-phase method means the first table with respect to Cj, reduce that table, then again you will come to the second phase, and also you observe how many dummy variables are required. 4 variables. So, you can add, this becomes 0 times t1 plus 0 times t2 plus some mu times lambda 1 plus mu times lambda 2. This is what is required, and eventually that mu would be 1 and you can start. So that these constraints, the constraints which are given in terms of your inequality, first of all you have to change it in terms of equality, and these dummy variables will help you. The variables that you have added over here, it is going to help you and they will give you the answer. Okay. So, make the table, make the first table in terms of that Cj, reduce, obtain the optimum solution from here, and then you start your second phase. Okay. Only the simple application of the method you can just apply. Do not forget to change the function, do not forget to change your z dash, because the function was the minimum problem and you have to change that. Now, yes, this was again from the real analysis section, a very important. In the real analysis, this is a very important topic, Riemann Integrable. So, function was not a very difficult function, simple, x square, you know the nature of the x square is decreasing in the negative x axis, increasing in the positive x axis. Over here also we have an edge, why? because they are not talking about the negative, they are not including both of the negative and the positive section of the x-axis, they are only taking from 0 to k. K is strictly greater than 0. So, the section is like that, right? And whenever in the Riemann integrable functions, because the question is telling you to prove, show that f is Riemann integrable on the closed interval 0 to k. So, in that interval, if you observe, the function is a strictly increasing function. So, you don't have to worry about the interval, the maximum value in that interval, minimum value of that interval, because it is the increasing function. So, how to do that? Fx is equal to x square on 0 to k. The first job is to make a partition. This is 0, this is, let's say, k. First job is to make a partition. So, let us make a partition x naught, x1, x2 and so on, x. This is xi minus 1, xi and so on. Okay. So, I will talk about the general intervals, general subinterval. Over here, it is, if I take that to be n. So, I am taking a partition with n subinterval. So, p equals to 0, which is the first one, x naught. Then we have x1, x2 and so on till xn, right. This is k. So, basically it becomes 0, then we have k minus 0 by n. So, it becomes k by n, k by 2n, subintervals each of equal length. Okay. At the end it is k. This was the partition. So, if I talk about a general subinterval, let me take that to be xi minus 1 to xi. This is the general interval that we consider. Now, in this subinterval, let us talk about small mi and capital Mi, because that will help you to calculate your LPF and UPF. And after that, what you need to do? Lower Riemann integral and upper Riemann integrable, they has to be same. If they are same, then our job is, first part is done, that f is the Riemann integrable, and what is the answer of the lower Riemann integral and the upper Riemann integral, that is actually, that has to be k cube by 3. So, in the interval xi minus 1 to xi, what is your small mi? Small mi is infimum of all the fx such that x belongs to this ith interval, ith subinterval. Because my function is the increasing function, therefore this point is small, this will give you small mi and this will give you capital Mi. This is xi minus 1 comma mi and xi comma capital Mi. So, basically this Mi is f of xi minus 1 and this capital Mi is f of xi, right. So, there was nothing over here, this is f of xi minus 1. Now, what is xi minus 1? Xi minus 1, see, this is x naught, x1, x2. So, xi will look like xi, the general expression of your xi is k upon in. Okay, this has to be 2k by n, no? This is not. K by n plus k by n, like that. So, this is xi, it will be ik upon n. So, this is f of I minus 1 k by n. What is your function? Function is x square. So this is basically I minus 1 square k square by n square. Similarly, you can find capital Mi. This will be nothing but I square k square upon n square. What is your LPF? LPF is summation of mi del I. What is del I? Del I is the length of the interval. I have divided my intervals into the equal length. So del I is basically xi minus xi minus 1, right, and this is nothing but k by n, k by n. Substitute the value over here. This is I equals to 0 to n, not 0 to n, 1 to I equals to 1 to n. It becomes I minus 1 whole square k square by n square dot k by n. Summation is over I. Take that k cube upon n cube outside. You will have I minus 1 square I going from 1 to n. This is nothing but 1 square, the sum of the series 1 square plus 2 square plus 3 square, n plus 1, 2n plus 1 by 6. You will get n cube in the numerator also and n cube in the denominator also. Take that n cube inside, so that at the end when you are calculating the lower Riemann integral, this is nothing but limit n tends to infinity in your LPF, or what do we say, because I have written in terms of p, so you can also write norm of p going to 0. This limit you can also write norm of p going to 0, and then norm of p going to 0 is same as n tends to infinity, right. So you will get the answer. Same work is required for UPF, upper Riemann integrable. They will be same and your job is done. F is Riemann integrable. Okay. So just go through the method. Again, this is just the definition of the Riemann integrable. I have not used any theorem or anything like that, right. This is just the basic definition of the Riemann integration, how we call it integrable, and you can get the answer, right. This was from your real analysis. Now, second is again the group theory. Prove that every homomorphic image of a group G is isomorphic to some questioned group of G. Okay. So, every homomorphic image, that means you have to take a arbitrary homomorphic function from, let us say, some G to G dash. This is homomorphism. And this is given to you. See, again, be very clear what is given, what they want you to prove. This is given to you. What they want you to prove is every homomorphic image, means the image of this function, that means the range of this function is isomorphic to some question group of G. Okay. So, to proof is f of G is isomorphic to some questioned group of G. So, for some H normal to G. This is required, right. Now, if you want to prove this as isomorphic, you need a function. You need to define a function between this G by H to f of G. To be particular, let us take that H to be kernel of f. We know that will be normal. So for some H, let that H be kernel of f. There is no problem in that, and let it be K, so that it is just easy to write K f of G, right. Let us define that function to be Gk is equal to f of G. The way I have defined the function, it is onto. You do not have to even do a job for the onto, right, because I have taken all the image in the codomain. So, that part is done, right. And please do not forget about this point also, well defined. Students usually don't do that. They start from 1, 1 on to and homomorphism. Do this part also, very important, first place, right? You need to first of all check that whatever function you are defining, whether it is even well defined or not. If it is not well defined, then I cannot discuss these points. If it is not a function, then how can I discuss about 1, 1 onto and homomorphism? That is the second thing, right? So first prove well defined, then comes to 1, 1 onto I told you is very easy. Homomorphism will be actually concluded. This will be just the result from the parent function I have considered, that is small f. That is a homomorphism. The homomorphism property of the small f will help you to prove the homomorphism of your capital F. So this is also not a very difficult part. Over here only one result is required for 1, 1. How to prove function to be 1, 1? This is capital F of gk is equal to small f of g, right? Then this is the function you want to prove it to be 1, 1. If you want to prove it to be 1, 1, you have to start with let f of g1k is equal to capital F of g2k, right? What does that mean? That means f of g1 is equal to f of g2. Now, f is not 1, 1. If f would have been given 1, 1 also, you can just write g1 is equal to g2 and done. But you see, that is not given in the question. So, you need a different approach. What is that different approach? You multiply f of both sides with f of g of inverse. So, this is f of g1, f of g1 inverse, f of g2. Okay. Why? F of g1, that is in g dash, that is in g dash is a group, inverse will exist. So, there is no problem in the existence of that element that I am using here. Okay. So, this becomes identity of what? Identity of g dash. So, let it be e dash equals to f of g1 whole inverse. Now, you see, f is not 1, 1, but f is homomorphism. That was the one thing that was given in the question. This is a homomorphism. Use the property of homomorphism over here. You can take that inverse inside. This is nothing but g1 inverse. This is g1 inverse and f of g2. Again, use the property of the homomorphism. You can write g1 inverse g2. F of g1 inverse g2 is e dash. That means this belongs to the kernel. It implies g1 inverse g2 belongs to the kernel of F. After that, we have a result. If A inverse B belongs to H, it implies AH equals to BH. That is what is required. So, this is kernel of F is actually K. So, it implies G1K equals to G2K and 1, 1 proved. So, 1, 1 was not so direct, but again not a very difficult job here also. Onto the other points were quite easy. Onto homomorphism and well defined as well. Okay. So, do not forget about the first point as well. This was it. This was the question number 2 from the group theory for 15 marks. Let us come to the C. This is again C part of question number 2. We have again the question from the complex analysis. Over here, what you can do, you can consider a different integral in the complex analysis, solve it, take the real part or just equate the real and the imaginary part so that you can get the answer of this integral. Got the idea? So, you have to consider with a integral in the complex. So let us start with some fz dz. What your fz will be? Fz is where you consider this where f of z is e raised to the power iota z upon z square plus a square, z square plus b square. You have to start with the integral, but integral you have to do the integration over a contour. Let that to be a semicircle over here, again from minus r to r, right. We will do the integration over this curve C. The denominator, work with the denominator. Over here it can be written as z minus iota a, z plus iota a, z minus iota b and z plus iota b. Simply using of your Cauchy residue theorem will help you to evaluate this integral. Cauchy residue theorem, again a very important part of the complex that we do in the very starting when we discuss this integration. So in integration you need Cauchy residue theorem, that was required in this question. And what is it? This is actually the integration. The integration is 2 pi iota multiply sum of residues. This was your Cauchy-Riemann integral. So all you need to find is the residue, add them up and write it, just substitute over here and you will get the answer for your integration. Now the residue, for residue of your fz at z is equal to iota a. So residue of fz at z equals to iota a, this will be nothing but limit z tends to iota a f of z multiply z minus iota a, right. So you will get e raised to the power iota a iota z upon z plus iota a and z square plus b square, right. And apply the limit, you will get, this is iota a, so it becomes e raised to the power minus a upon 2 iota a upon a square minus b square, right. B square minus a square, b square minus a square. I have just applied the limit directly, so just move this. So after applying the limit, this is the answer. This is your b square minus a square. This can be written as minus e raised to the power minus a upon 2 iota a square minus b square, right. And in the similar way you can find the residue at z is equal to iota b also. Over there you see what will be the changes. Over here you will get e raised to the power minus b 2 iota b, and over here a square minus b square, minus will not come here because there we have iota b, and you add them, add both of them, 2 2 iota a square minus b square, it can be taken common outside. Not a, actually only this section, 2 iota and a square minus b square. When you add both of the residues, you substitute back here, you can take common 2 iota a square minus b square, 2 iota is cancelled, you can get the answer. But again, that is the integration of fz, not this. So you can just write your integration of fz dz as minus r to r fx dz. But again, what will be the changes over here? This will be minus r to r f, this is e raised to the power minus iota x, e raised to, not minus, iota x, and over here x square. Okay. So this is e raised to the power iota x upon x square plus a square, x square plus b square dx, right? And then you can take just limit r tends to infinity, you will open this formula cos x plus iota sin x. For the real part, for the part minus infinity to infinity, real part is cos x upon x square plus a square and x square plus b square dx. This is what is required, and the answer that you are getting, take the real part from that and that will be your answer. Okay. So only the job was to consider the starting integral, after that solve that integral and separate the real and imaginary part, you will get this answer. Okay. So easy. Question number 2, then again question number 3, first part again was from the integration complex analysis. Complex integration is there. Now first job is to find the zeros of your denominator. This is z square plus 2z plus 5 equals to 0, then z equals to minus b plus minus b square minus 4ac upon 2a, it becomes minus 2 plus minus iota 4 by 2, so it becomes minus 1 plus minus 2 iota. But so the zeros of the denominator, one is z1 minus 1 plus iota plus 2 iota, z2 is minus 1 minus 2 iota. So these are your two roots, but those two roots, I have this c is given to me, curve is given to me. These two roots I have to check that are they lying inside the curve, within the curve or not. If they are not, then I don't need to consider this. If they are, then again use the Cauchy residue theorem, right? And you will observe, if you see, this is just a circle, so minus 1 plus 2 iota. Okay. So this z1 actually lies within the C, but this does not, right? So this lies within C, this does not lie within C. So we are not concerned about Z2. So what we need to do? Calculate the residue at Z is equal to Z1. Only that one is required. So residue of Fz at Z equals to Z1 is limit Z tends to this. So that means you just have to substitute the value of Z as Z1 at the end, and this will be Z plus 4 is in the denominator, is in the numerator. So basically your Fz is Z plus 4 divided by Z minus Z1 and Z minus Z2. I'll multiply Fz with Z minus Z2. So Z minus Z2 in the denominator, it will get cancelled out. I am only left with Z plus 4 divided by Z minus Z2. Just a second. This does not lie. Z1 lies. So I need to put, yes, so it becomes at the end, the answer for the integral 2 pi iota, it becomes Z plus 4 divided by Z minus Z1 and put Z equals to Z. Simple. Okay, this was easy than the last one. Only one residue is there, just substitute the answer, apply the Cauchy residue theorem and you can obtain the answer for your C directly. Okay, this was from again complex analysis. Now, yes, this is third question, B part. What is given to you? Find the maximum and the minimum value of this expression when Lx plus My plus Nz is equal to 0 and this interpret the result geometrically. Okay. You have to find the maximum or the minimum value of our expression. Okay. What you can do, this is, let this expression be, let's say t. So I have to minimize or maximize my t with respect to the given constraints. Two constraints are given. Just like the way we do in the try to find the values. Try to find the value of x, y and z. Okay. At the end, whatever is your x, y, z, for which values of x, y, z, this expression, the expression t is giving you the minimum or the maximum value, right? So how to calculate? T is given, you have to minimize minimize or maximize the t, put dt is equal to 0, right? So what is dt? dt is actually 2x upon a raised to the power 4 dx plus 2y upon b raised to the power 4 dy plus 2z upon c raised to the power 4 dz substituted with 0. You have additional two informations, Lx plus My plus Nz. This differentiate this also. This becomes L dx plus M dy plus N dz equals to 0. Differentiate this also. This is 2x upon a square dx plus 2y upon b square dy plus 2z upon c square dz equals to 0. Right. Now, you have to minimize this. These are the two constraints. So, you multiply them with a constant. Let it be lambda and mu. Multiply the first expression with 1, second expression with lambda, third expression with mu, add them, equate the coefficient of dx to 0, equate the coefficient of dy to 0, equate the coefficient of dz to 0. This is your job. So, if you multiply, you see, this becomes 2x, I am going to write it here, 2x upon a raised to the power 4 plus L lambda plus mu times 2x upon a square equals to 0. You can actually eliminate this 2 also. You can take that 2 common out to 0. So, I am not writing 2 over here. Let us just remove that. Okay. So, it becomes x by a raised to the power 4 plus L lambda x upon a raised to the power 2 equals to 0. This is the coefficient of dx that you are obtaining. What I am doing, multiply expression 1 with 1, x by a raised to the power 4 plus lambda n plus again x mu x mu upon a square is equal to 0. Do the same for by equating the coefficient of dy to 0 and coefficient of dz is equal to 0. Again you will get expression 4, equation 4, 5 and 6. How you can solve this? Let us write that this is y upon a raised to the power 4 plus m lambda plus mu y upon b square equals to 0, right? And then z upon a raised to the power 4 plus n lambda plus mu z by c square equals to 0. This is your sixth expression. Now what you can do? You can actually multiply them by, because I want the expression, see, I want this expression x square plus a raised to power 4, this value. So what you can do? You can multiply this with x, you can multiply this with y, you can multiply this with z, add them, you can get a value of lambda. You can get a value of lambda and then use that value of lambda to calculate the value of x, y and z. Those value of x, y and z will give you the maximum or the minimum value of your expression. Okay. The same way in the method that we have done to find the maximum and the minimum value of an expression. They are in 3 variables. This is how we do it. Okay. So again LPP problem there was, and this is the first method, the very first method that we discussed, simplex method. It requires the formulation of the table, again optimize the solution from that, and given expression is maximized, you do not need to change it. So there is one additional part, write the optimum solution of the dual from the optimal table of the given problem. Okay. So one additional part that you have to do is dual of the primal problem, that also you need to calculate. Okay. So this was nothing, just the direct application of the simplex method in LPP. In LPP actually each method, it requires just the practice. They are not a very tricky type of questions. Just be familiar with every kind of method, big M method, two-phase method, simplex method, there is Vogel's approximation method, right? All those things, whatever the methods are, just be familiar with the starting portion. This is how the algorithm of the method works, and the questions are asked directly, so you can apply them. In the paper 2, the LPP portion, I think it's the one of the easiest, and even the computational part where you have that some of the portion in the computation is also very easy. Okay. This was the first question from the ring theory. From the ring theory, the question is asked, let R be the field of the real numbers and S the field of all those polynomials fx belongs to Rx such that f of 0 is equal to 0 is equal to f of 1. Prove that S is an ideal. So again, just the definition of being an ideal will work over here. Is the residue class ring Rs by S an integral domain? Give justification for your answer. Okay. So for the ideal part, first of all, what is your Rx? Rx is set of all polynomials in X, right? And S is set of all those polynomials such that f of 0 is equal to 0 equals to 1. So f of x that belongs to Rx such that f of 0 is equal to 0 equals to f of 1. What we want to prove is S is ideal. What is the definition? There are 2 points we need to satisfy for S being an ideal. What is that? First is you take a f belongs to S, you take a g belongs to S, and you have to prove that f minus g also belongs to S. This was the first point. What is the next point? You take a h belongs to S and you take a f belongs to R of x, and then you have to prove hf belongs to S. These are the 2 points required. See how easy they are. This is, if you are in for the first point, if you are taking a f and g, they belongs to S, that means you have the property f of 0 equals to 0 equals to f of 1, and similarly for g of 0 equals to 0 equals to g of 1. You want to prove the same result for f minus g. So, to prove f minus g of 0 is equal to f of 0 minus g of 0. They both are 0 minus 0 is 0. That is also equal to f minus g of 1, because again same result, this is also 0. Proved. First part is done. For the second part, you take h belongs to S and a function from the f belong to the Rx from the original ring. Now you have to prove that hf again belongs to S. How? hf of 0. This is the multiplication of the function, not the composition of the function. This is h of 0 multiply f of 0. H belongs to capital S, that means h of 0 is 0. This is 0 multiply f of 0, the answer is 0. Do the same calculation for 1 as well. H of 1, f of 1, 0 multiply f of 1 again, sorry, this is 0 na, 0. So, proved. Therefore, HF belongs to S. First, both the parts are done. So, you have proved that S is an ideal. Now, there is one more part of the question. Is the residue class Rx by S is an integral domain? Okay. So, over here what you can do, if you want to prove that this is not an integral domain, an example would be enough. Example would be enough. You can try by an example. So, what example would work here? See, R ring, okay. You can try with a S generated by a polynomial. Take that polynomial to be x square, x plus 2 whole square, and in Z, no, Z2x, just a second, you can do this, x square, you can do x, this is 4, I want this x, so again x plus 2. You can take the example, see, you can take the example x plus 2 plus your expression. You can take this example z3x over x square plus x plus 1. Start by x plus 2. If this is I, let us say, ideal I. So, start with this. It belongs to I, it belongs to Z3 by I, Z3x by I, right? But you take the square. If you take the square, it becomes x square plus 4 plus 4x. We are in Z3, so it becomes x square plus x plus 1 plus I. So, this is nothing but the 0, the identity part, but again this is 0, but this is not an integral domain. Okay? One example would be enough. We are in question number 4. This is question 4, second part. Test the convergence or the divergence of the series. This was again a very easy question. You just have to apply the test of the convergence and the divergence of series. Also the general term you can write, if I take the general term to be f of n, it becomes n raised to the power n x raised to the power n upon n factorial, right. I think ratio test will do the job. See, for the ratio test, if you are limit n tends to infinity f of n upon f of n plus 1. This is the ratio test. Apply the ratio test over here and you will get an answer for which less than 1, greater than 1, you can apply the condition, you will get an answer. But for equals to 1, again you have to consider a different case. For equals to 1, there cannot be a direct deduction, it can be made. So, apply the result for equals to 1 when your this limit f of n plus 1 equals to 1, you will get a condition on your n. Take that n value, whatever it is, let us take it to be a, back in the general term and apply the different result to prove the convergence or the divergence of the series. Okay, only these two things. When you will substitute that, when you will discuss the case equals to 1 separately, over there again a test is required. But in the starting, ratio test will do your job. So, at the end, merge all the results together, that is your answer. This was simple question from the real analysis again. See, I was talking about this Vogel's approximation method. Again, the LPP, transportation problem is there, transportation problem, assignment problem, very commonly asked. So, do not miss them. Please do the maximum practice. Take 1 day for all the transportation problem, take the 1 day for all the assignment problems, 1 day for all the transportation problem and assignment problems, right. And again take out the time for every method also, okay. Please get familiar with every method. Vogel's approximation method to find the initial basic feasible solution. After that you will work on the tables to find the optimal solution. Again how you work in the Vogel approximation method? Basically, you find the difference between the smallest cost, between the smallest cost and the next to the smallest in each row, in each column, and you continue to find to make the table to find your initial basic feasible solution. Once you have your initial basic solution, apply use that solution to further optimize your solution, and I think after getting the feasible solution you will get 2 to 3 steps to get your minimum solution and the transportation problem will be solved. Okay. LPP problems they require, even in the exam, they requires time. So, even while doing the calculations or while changing that plus to minus, using that parenthesis, writing that value over here, don't do that, do any mistakes. Be focused, because see, 20 marks question, okay, and even you are doing a mistake in that a silly mistake in any calculation, or sometimes minus sign, it just vanish in the next step, it goes somewhere. So, do not do these silly mistakes, do not do the mistakes at least in calculations if you know the solution, if you know the method, algorithm to prove. So, you can just use the method. If you are not familiar in LPP with any of the method, I'll suggest you not to touch these kind of questions. Unnecessarily waste of time, and this is not a kind of question that you can go by hit and try. Okay. So, if you know the whole algorithm, you have practiced the questions, this question would have been nothing. So, you can solve that. Now, the section B starts from here. It is given that the equation of any cone with the vertices with the vertex at ABC is f of x minus a upon z minus c comma y minus b upon z minus c equals to 0, right. This is your equation of cone. They are telling you to find the differential equation of the cone. What is differential equation of the cone? That is P plus Q equals to R. You know how to calculate P, capital Q and capital R. In that case, what is the formula? The formula is, if you take these two as some functions, if you take this to be S, if you take this to be the function. So, this is a function of x, y, z. S is a function of x, y, z. Again, t is a function of x, y, z. Then, how to calculate your p, q, r? They are nothing but, let me write it over there. I have taken S and T. So, the differential equation of the cone is given by this PP plus QQ equals to capital R, where your P is Jacobian is required. Why is it? You can do that simple calculation. S is given, T is given, you have to just substitute the value, find out the Jacobian and back substitute over in this equation. Capital P, capital Q is del ST del ZX and R is del ST upon del XY. Just substitute the values and you will get your answer just by the substitution. So, again, for how many hours, this was for 10 marks, right. So, again this question was the easiest question, I think. So, Gauss elimination method, I don't even think that any discussion is even required. One question was there in your paper 1 where you have to reduce your coefficient matrix to the row reduced form. It was written in the question that you have to reduce the matrix in the row reduced echelon form, and then you have to solve the linear equations. Over here, the Gauss elimination method. What is Gauss elimination method? Basically, all you need to do is take the coefficient matrix and do the same thing, reduce it to the echelon form. So, just a second. 18, 13 and 14. Reduce it to the echelon form. Also the so at the end basically you will make these 3 elements as 0. Once these 3 elements are 0, you can directly get the value of z from here. Substitute that z, because now you will get, after this you will get 3 equations. You will get 3 equations. It will be of the form a1x plus b1y plus c1z is equal to some b1. Second will be b2x plus c2z will be equal to b2, and the last will be c3z is equal to this is c2z, C2Z is equal to B2 and C3Z is equal to B3, because these three are you have obtained 0 in these positions. So in the last equation will directly give you the value of Z. Put that value of Z in the second equation, you can directly get the value of Y. You have the value of Y and Z, substitute in the first one, you can get the value of X. Right? This is the Gauss elimination method. Again, while solving the system of equations, you have some methods, Gauss elimination, Gauss Jordan, all the methods, just go through them because direct question has been asked. So this was question number 5. This was from question number 5. Again, for question number 5, okay, in the first part was convert the number base 10 into octal, that means base 8, and the number from base 10 to the hexadecimal, that means base 16. See, calculations are required over here, but again the portion from the first part, when it comes to the octal, 1093.21875, this was the given number to the base 10. You have to convert it into the number to the base 8. This is the question. How you deal with the whole part? This is the whole part, this is the fractional part. To deal with the whole part, whether it is the base 8 or the base 16, that is easy. What you do? You just take the 1093, right? Divide it by 8. Do the calculation. This will be 136 and then remainder is 5. Again with 8, the quotient is 17, 0. With 8, quotient is 2, it is 1, and with 8, 0 and 2. So basically you are getting nothing out of the last division. So just these 5, 0, 1, 2 is required. 5, 0, 1, 2 in the upward direction. So 2, 1, 0, 5. This is the whole part for base 8. For fractional, how you work? For fractional, 21875. 0.21875. Right. First is, because I want to convert into base 8, you just multiply this by 8. You will get a number, right? In that number, separate again the whole part of the number and the fractional part. This is the whole part of the number and this is the fractional part. Right. If you multiply this with 8, you will get 1.75. Whole part is 1, fractional part is 0.75. If your fractional part becomes 0, which is not the case over here, fractional part is not 0. So, I will continue. I will write 0.75, I will again multiply with 8, write the whole part and the fractional part. Over here, you will get the fractional part as 0, you will get the this as 6, so this is 6.00. Now, you have to take this in the reverse order, just like the way we did here, number in the reverse order, 2105. So, 2105.61. 61, done. If you know how to calculate, how to convert it, there was nothing, direct question was asked. Even from the hexadecimal, in the hexadecimal you know the the conversion from the decimal to the hexadecimal, how it works? It works like, for the second part, it works like 1, 2, 3, 4 till 16. Till 15, it will be, so let us start with 0 instead. So, let us start with 0. 0, 1, 2, 3, 4. This is to the base 10. To the base 16, how we denote that? From 0 to 9, there will be no change, as it is 0, 1, 2, 3, 4 and so on till 9, it works like that. But after that, after your 10, it works like A, B, C, D, E and F. Right. So, this is just the representation. This is from the decimal to your hexadecimal, and same kind of job is required. You will divide it with the, take the whole part, divide it with 16, collect all the question, collect all the remainders, take that in reverse order at the end, and same case for that. Okay, all the calculations are required. Express the Boolean function this in the product of max term forms. Okay, max term form. How to do that? First of all, you can always separate this in the multiplication. In the multiplication we have xy, no? So, we can always separate this in the Boolean function. This is xy plus x dash z, xy plus x dash z. Okay, so I will do it. This was not the second part, right? This is not the second. I will shift this to the side. Right, let us start the second part. In the second part, the f x y z, it was given to us xy plus x dash z, xy plus x dash z. It is very simple to just separate these. How? First, let us separate this. So, it becomes x plus x dash z, y plus x dash z. Same kind of thing you can do for the x dash z also. So, it becomes x plus x dash, x plus z, y plus x dash, y plus z. Right, and then you know x plus x dash, it becomes 1. So, I am only left with these 3 brackets, and in these 3 brackets you can, just a second, this was x plus, so introduce the variables x plus y dash is again 1 plus 0. So, y dash is 0, that is why I am adding this again. So, this is x dash plus y plus z dash and x dash plus y plus z, right. What else? You can now again separate each bracket into 2 parts where you will separate this z dash. So, this will become x plus y plus z, x plus y dash plus z, x dash plus y plus z, x dash plus y plus z dash, x plus y plus z, x dash plus y plus z. And we have any similar brackets? These 2 are similar brackets, they will vanish. I am only left with these 4 brackets, that is your max term. Okay. So, just the simple this was required. This is 1, x dash is 0, a is 1. Okay. These things was required and you can obtain your result. This was the second part. Again, for the 10 marks, it was nothing. It was in max term form. Now, again question number 5, D part. Question is, a particle at a distance r from the center of force moves under the influence of the central force. how many times we have done the concept of Lagrange's and the equation of motion in the class. So that's again the direct question has been asked. All you need to do, calculate the kinetic energy, calculate the potential energy, calculate your L. L means the Lagrangian, then use that to find the motion of the derivation. So initially what you can do, T means kinetic energy. Kinetic energy, it is half mv square. So you can start with the expression T, that is half mv square, but in terms of polar coordinate, if I take r theta to be that coordinate of the particle in terms of the polar coordinate, r theta, if I take this r theta, then that v square expression, it will be changed to half m r dash square plus r square theta dash square. This is the expression of your v square in terms of your r and theta. T is done, and f is already given minus k by r square, where k is a constant. So this will help you to actually calculate your potential energy. So this is the kinetic energy from equation 1. F, how it will help you to calculate the kinetic energy, this is, we can use the another expression for the force. Force is in terms of the potential energy, it is minus dv by dr, where v is the potential energy. So I can use that minus dv upon dr. Equate these two, differentiate, find the value of capital V. So you have to not differentiate, sorry, integrate. You have to integrate in with respect to r. If you integrate this, what you will get? This is equals to minus minus cancel k, so 1 by r square dr. So it becomes minus k by r, right, and your at a distance r. So from minus infinity to r, from minus infinity to r, right, in terms of r. So the answer is minus k by r. This is your potential energy. You have your kinetic energy, potential energy, just calculate the L Lagrangian, that is L equals to T minus V, substitute the value, and the next is equation of motion. Now equation of motion you can calculate in you will calculate in terms of both r and theta. So that is d by dt of del L by del r dash minus del L by del r equals to 0. This will give you the equation of motion in the variable r. Same kind of thing will happen in the theta, d by dt del r of del theta dash minus del r by del theta equals to 0. These are the two equations. They will give you the equation of motion. Okay. So again simple, substitute all the values over here and you can get the answer. Next, again fifth E part, the velocity component of an incompressible fluid. I hope you know the meaning of incompressible fluid, that is in fluid dynamics we have done that. In spherical polar coordinates are theta and xi. See, because the change of coordinate has happened, so you have to get out of that notation I cap, j cap, k cap. Now we are in scalar factors. You will use the scalar factors instead. Scalar factors in terms of your r, theta and xi. So basically you are using er, e theta, e xi, right. That is in the spherical polar coordinates we have er, e theta, e xi, right. Let's see what the question is. this is the velocity component. Okay. Okay. So, velocity component, that means Vr is given 2mr minus 3 cos theta, V theta is given small v, these are small v, theta is equal to mr minus 2 sin theta, and V psi is equal to 0. Components of velocity are given, where capital M is a constant. Show that velocity is of potential kind. Find the velocity potential. Okay, so we have velocity potential and this is the velocity. So, I'll use the different notation for the velocity potential, not V, let it be capital F, okay, and the equation of the streamlines. Okay, so basically 3 jobs. First, show velocities of potential kind. Second, find the velocity potential. Third, equation of the streamlines. Three parts was there. So, how to start? See, since velocity is given, what you can do? For the velocity potential, we can actually, how to do this one? How to show velocities of potential kind? Curl has to be 0. That is simple job, nothing to do. Curl has to be 0. Curl of this V having the 3 components. Curl of this has to be 0, but again we are not in Cartesian. So, I cap, j cap, k cap will not be there in the curl. Curl of your V will have e raised to the power er, r e theta, r sin theta, e xi. Right. Rest are same. Rest is del by del r, del by del theta, del by del xi, and the components over here. Do the calculation, this has to be 0, then we can prove the first job is done. Velocity is of potential kind. Second, find the velocity potential. How to do that? Use your equations. Use your equations. What is this? The components of your velocity. You have to find velocity potential. If velocity potential is capital F, what is this first expression? This first expression, let me write it. This will be the 3 expression, and you can just equate it. So, this becomes the first expression minus del f by del r. Second, minus 1 by r del f by del theta, and the last del f by 1 upon r sin theta del f by del xi. Okay, you have to solve this to obtain your capital F. Then streamline. The equation for the streamline is given by dr by qr. Okay, so that you can obtain with the help of equation of streamlines. It will be given by dr by qr equals to r d theta by q theta and r sin theta d phi by q phi. Again, just remember the scalar factors. The scalar factors, every formula, there is the only difference of those scalar factors that we use in the spherical coordinates, right? there is no problem in this. See again 1 r sin theta and q theta q phi. Okay, solve this, you will get the streamline. So again 3 parts were there in this question. Now we have heat equation. Heat equation, this takes a, you know, it's a very lengthy question. You have to solve, you have to assume that solution mu u x t. We start by taking a function x in terms of x, t in terms of t. That's how we started, right? And yes, and you start applying the equation and all these things. So it is basically simple, direct question was asked from the heat equation. So you saw that is actually wave equation, heat equation, direct questions are asked. But again they are lengthy but not difficult. So try some questions to get, you know, a brief knowledge of the method, the application of these methods, and you can just apply these methods to obtain your answer. Okay, this was for 20 marks. Again, if you have done practice for these heat equations and wave equations, you can solve it. Direct question from partial differential equation. A circuit corresponding to the Boolean function f x y z. Okay, so let me write it x dot y dash plus z times, no sorry, this is actually x y negation plus z plus y. So this is x y dash plus x z plus y. This is your function, right? The question was asked to find a circuit corresponding to the Boolean function that is given. Okay, not a very difficult job. Let me just shift it, x y, let me just write it over here. F of x y z is equal to x y dash plus x z plus y, right? You have to make a circuit corresponding to this. So this is simply start with the input x, y and z. Start with the input x, y and z. Now I want to multiply x and y prime. So let us just change it to your y dash, right? After that I need multiplication x y dash. This is representing x y dash. Now I want to multiply my x and z. So this x and this z, overlap of the circuits. So this will actually become this, right? And so what you can do, because I want x from the, okay, so let's just make it like that. Do the same. Now I am multiplying x and z. So this is xz, y is as such. So let me take y from here, right? And all of them, this is y that I have taken before conversion to this y dash. So that is y, this line is y. So this is the final answer. I am going to add them. So this is my final answer. This is x y dash plus x z plus y. Nothing. Not a very difficult one, just the simple multiplication, the product and the addition is there. So this is the circuit diagram. There was one more question for the table. For the input, you see, for the input you are in Boolean function, what are the choices? 0, 1, 0, 1, 0, 1. So, how many combinations you can make? 2, 2, 2, total 8. So, in the table it will have 8 inputs and 8 outputs. So, this will be like x, y, 0, 0, 0, 1, 1, 0 and 1, 1. Right. Why I have written 2? Because for z I will have 2 choices for each of them, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. This is z. What you need to do? First of all, I want my y dash because I want to multiply, then everything, this is y negation, this is just for y, you have to change the value 1, 1, 0, 0, 1, 1, 0, 0. This is y dash. Then you have to calculate x y dash and x z. X y dash, x z, y, and at the end take the sum. Okay. Complete this table. This is your second part of the question where they were asking you to make the input output table. So, this is the table, right. Now, this was question number 6 B part. Again question number 6 C part. Moment of inertia of the cone, okay, about one of its slant height. Find the moment of inertia of the right circular solid cone about one of its slant sides, of course generator, in terms of its mass, height and radius of bases. This question requires again the lengthy question. I will count this as a lengthy question and the PDE question. But if you are attempting such questions, then the only one thing you should have, that I know how to write this solution. I know the solution. Only then start this. Don't, and I have told you, if you are making an attempt to the question that you think we don't know, but you can just try it sitting in the exam. So, don't waste more than 5 minutes to it on the thinking process. Okay, because there are so many questions, plus in the starting please do the questions that you think that they are very strong part of you and you can attempt those questions. So, go to those questions first. In this question we have to find the moment of inertia. You see, for the moment of inertia of the cone, mass, height and radius of the base. So, if I make the radius cone like this, I have to take moment of inertia. No? So, let us make it inverted cone, so that I can take y axis here, x axis here. See, so all the calculations are required. So, this is A basically, this should be in the center, okay. So, all you need to do, moment of inertia, find the moment of inertia along OX, because you have to add. At the end you will get the result for the moment of inertia by adding the moment of inertia along OX, moment of inertia along OY and moment of inertia along both OX and OY, and then add those things and you will get your answer. Okay. Height is h, that is given in the question, and slant side, let it be L. Okay. Just apply the formula, you will get your result. If you have done these kind of questions, this was nothing. Find the general solution of the partial differential equation, okay, and this. So, again the two parts, make the auxiliary equation, find the particular solution. Because we are in PDE, so the job is a little bit different. This can be for the auxiliary equation. See, for the auxiliary equation, first just can you convert this? Yes, of course, this is d plus 3d dash and d minus 2d dash, right. The auxiliary equation will become m plus 3 m minus 2 equals to 0. Solve the m, you can get your CF first. Don't forget we are in partial differential equation, okay. So, it is not that simple that we used to write. Now, to get the particular solution, what you can do, start by taking this d plus 3d dash d minus 2d dash, and over here I have x square sin x plus y, okay. What is this? How you can operate 1 upon d minus 2d dash? Again, a very initial, these are the initial kind of questions that we discuss in these kind of question in PDE. You can just substitute your constant as over here it will be, take a constant c, that will be y plus 2x, and over here when you will solve this it will be some c dash, it equals to y minus 3x. Right, and do the integration. So, basically when you are applying this expression d minus 2d dash in the denominator on that, so this is actually becomes z equals to 1 upon d plus 3 d dash, and you are applying this, so it is converted into the integration, and integration calculate the y is c minus 2x, change this y into c minus c minus 2x. So, it becomes x square sin x plus c minus 2x dx, right. And do the calculation. When you will apply this, the change the y is as c dash plus 3x, and again you can do the integration, you will get the answer. Okay, the initial kind of problem. So, done. Easy question, a very easy question was asked, although we have the preparation was for even much more difficult question from the numerical analysis. Numerical analysis, one this question was asked, one another question I think at the end. So, only 2 questions are asked. And Simpson 1/3, a very important, very commonly asked Simpson 1/3, you just have to remember the formula. See, the values are given to you, f0, f1, f2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, 2, 4, 6, 8, 10, 12, 14, 13, okay. So, we have no problem in there also. We have till f9. So, what is the formula? You just need to memorize the formula. What was the formula for the Simpson? The integration is from 0 to 20, okay. Approximation in kilometers, total distance run in 20 minutes, okay. So, we have to calculate it from 0 to 20. In that scenario, we will have a V0 also, the velocity of a train which start from rest, okay. So, you have to add one entry over here, see, you have to add one entry because train which start from rest. So, for t0 the velocity is 0, start with that value. So, this is f0, f1, f2, and in case this becomes f10. Now, you can apply the formula because we are in Simpson 1/3. What is the formula of velocity total distance? Yes, so the velocity in terms of dt, it becomes 1 h by 3, h is 2, the distance is 2, 2 distance is there, and this is f0 plus f10, then 4 times f1 plus f3 plus and so on. You see this last number, and 2 times f2 plus f4, and see the last number. Done. Okay, just apply the formula. These are the values from the question. Do the calculation. Again, question number 7. 2 points vortex each of strength k are situated this a vortex of strength. Okay, fluid motion is stationary. Also find the equation of streamline. Equation of streamline, one question was initially asked. If the streamline which passes through the stagnation point meet the x-axis at this, then show that. Okay, to show again a bit of a thinking is required, but I don't think you can at least make the attempt for this question. Fluid dynamics, the equation of streamline is given by the same. You can change that to the coordinates x, y over here, because over there I have in the polar coordinates, right. So, you can change it over here and attempt the question. A bit of a thinking was required in this question. 8th canonical form, again to reduce to the canonical form of the again to reduce it to the canonical form, it requires some effort, right. Again the series of formulas are required, that is first of all compare the partial differential equation that is given to you. So, this becomes RR plus SS plus TT plus FXY plus F is equal to 0. Make the comparison. If you make the comparison, you can get R y S is x plus y and T is x and F is 0, right. After that, because the canonical form is required, reduce the partial differential equation to the canonical form. How to start that? S square minus 4RT, S square minus 4RT. So, it becomes x plus y whole square minus 4y and then Tx. So, it becomes x square plus y square plus 2xy minus 4xy. It becomes x plus x minus y whole square, right. After that, what your job is? This is hyperbolic, right, because it is strictly greater than 0 for x not equal to y. For x not equal to y, this is greater than 0. So, this is your hyperbolic. How you work in the hyperbolic? Apply those rules, convert it into the canonical form. Once the partial differential equation is converted into the required canonical form, you have to, it becomes easy to solve it, and you can just apply that section over here. Okay. Now, yes, Runge-Kutta method. Runge-Kutta, this was, I was talking about this question when in the numerical analysis we have two questions, one from the Simpson 1/3 rule and the second is from Runge-Kutta method of the 4th order. Again, if you know the formulas, remember K1, K2, K3, K4, then K is required, H is required. If you only remember those formulas, you can just apply it over here. There was nothing this. Use 4 decimal places for calculation and step length 0.1. Step length is already given 0.1. So, for this starting step, how you can start the calculations? There is some initial approximation. Initial approximation is given. That means for x naught 0, you have y naught equals to 1, right? And then you have your h that is given in this question. Step length is 0.1. What was the formula? Formula of your K1? K1 is nothing but h times f of x naught y naught. K2 is h times f of x naught plus 1 by 2 y naught plus, sorry, this is h by 2, this is h by 2, and the second requires the calculation, the use of this K1 that you have calculated, K1 by 2, right. And then you have K3 also. K3, it requires your K2, so this is h times f of x naught plus h by 2, right, and y naught plus K2 by 2, y naught plus K2 by 2. For K4, you have h f of x naught plus 4, because we are in 4th order, so I'll have x naught plus 4 and y naught plus K3, y naught plus K3. Substitute all the values. You already have your f of x comma y. This is f of x comma y. This is x plus y square, right. So you calculate everything, you substitute all the values, you can get the value of K1, K2, K3, K4. At the end you have K also. K is 1 by 6 of your these values. This is K1 plus 2 times K2 plus 2 times K3 plus K4. You can get the value of K also, right. What else? Now, when you have the value of y naught plus, so step length is 0.1. So initially the given condition was on 0. So 0 plus 0.1. So the next answer will be, whatever will be your answer, the value of k, that will be y of 0.1. Y of 0.1. So this y of 0 plus 0.1 will be y naught plus k. So this is y naught, that is one, y naught plus this value of k. This is step 1. How many steps are required? That is given right here. Use the 4 decimal place for calculation. Just a second. Yes. So calculation requires 4 decimal place. In the step 2, where you have started with this condition, y naught 0, x naught 0, y naught 1, x naught now becomes 0.1 and y naught becomes y1, which is this value, y naught plus k. This you will have a definite value, a number will be there. So you will use that and again apply the same formula to get to your answer. Okay. So basically this was the another question from the numerical analysis. In the numerical analysis portion, usually in the graduation, most of you are not familiar with it, with the method. This is the different method that is in our syllabus, but I have seen that most of you, even those who have done the numerical analysis, they have not done this method, but again in this exam point of view, this method is very important. Last question, this is the last question again from the fluid dynamics. It was asked, verify that W is equal to iota k, W equals to iota k log of z minus iota a upon z plus iota a is the complex potential of the steady flow of fluid about a circular cylinder, where the plane y is equal to 0, okay, it is a rigid body, Find also the force exerted by the fluid on unit length of the cylinder. Okay. So, again much of a work is required. So, basically xi is given to you, okay, phi. So, W is given by u plus iota v, where v is given to you, right, and the streamline over here will be given by v is equal to constant, right. This will be the streamline, and once you have the value of v, you can get the nature of the circles, and you can then find the force with the formula. So, it again requires a bit of formulas, sequential use of the formulas. Use those formulas and get the answer. Again, it was for 20 marks, and it was a lengthy question also. Again, for the fluid dynamics, it was a lengthy question. In the fluid dynamics part, most of the students, they leave that section because of the, it's not a very hard, it's not a very easy part, and it's very, it's a weak point for most of you who has taken the mathematics. But I am telling you, even that's, I am saying, you can't be perfect, but a certain level of perfection is required in every subject. So, even the fluid dynamics you have not studied in your graduation, and this is your weak point, go through at least the basics. At least the basics. If the question of the basics are asked, then you can attempt the question. Otherwise, just leave the question. The question of that velocity potential, that was easy. Yes, this is difficult, but again, if you are not able to solve this question, just leave it. You don't have to see. At the end also, you are not going to attempt all the questions. You have to attempt only 5 questions, right? But going through each and every topic at least will give you the familiarity with the easy. You can differentiate between the easy and the difficult. So, if the question is easy, you can just attempt it, right. So, I think this was the last question. Yes. So, this was the last question, and this was the paper 2, and basically all the solutions, all the questions I have discussed in details. So, please try. I have not completed each and every question. Please try it by yourself, and the discussion of paper 2 is finished over here. If you are preparing for 2023, so again my suggestion would be, please do not leave any topic, number 1. Number 2, please do all the PYQs also, and maximum number of questions. Any topic, do the maximum number of questions. Yes, theory part is required for the basic understanding, but again, if you have the correct guidance, because the domain of the UPSC syllabus for the mathematics is very big, and even in that syllabus, if you are putting some things from the outside, it will be very difficult to complete the syllabus on time, and along with the revision. Revision is very important. Very important. If you have just completed the syllabus and you are going to the exam, you will not be able to solve any question efficiently. Okay, so the revision is very important. So, you have to restrict yourself to the syllabus, and only confine yourself within the syllabus, so that you can have the clear vision of what you have to target, what are the targets that you have to complete. Okay, so this was it. Thank you so much for this session.